Hello! In the first video, we introduced the time value of money concept with this example. This is exactly the same as in the first video. I've just rewritten things and I've also put them on a timeline. I would recommend putting data on a timeline, especially if you're new to finance, because it both facilitates your understanding and minimizes the probability of making a mistake. So in that example, I deposited $100 in a bank, and given a 5% annual interest rate, which I denote with R over here, that amount grew to $105 in a year's time. You can see the calculation over here. It's a simple one, but in case you have difficulty in understanding this, please rewatch the Introduction to the Time Value of Money video. Now, in the previous video, we saw that we cannot just compare various amounts at different points in time in absolute terms. For example, if I offer you $120 5 years from now at t equals 5, or $100 right now at t equals 0, you shouldn't say 120 is greater than 100, so I better get the 120. In order to compare the two amounts, you need to have a common base. And how do you get that common base? By translating the amounts at the same point in time. And at the end of the previous video, we said that we will do so by calculating present values, PVs, and future values, FVs. These are extremely important concepts, and you will also realize this as you enhance your financial knowledge. So let's introduce these concepts. The present value translates the value of a given amount in today's terms. That's why it's called the present value after all. So moving back to our example, this $100 resting at t equals 0 is in present value terms. So this is the present value. I will denote it this way. PV subscript 0. P for present and V for value, of course. And actually, the subscript 0 that I use in the notation is redundant because the present value gives us the value at t equals 0, that is today, by definition. Now moving on to the future value, this amount that rests at t equals 1 is the future value at time 1, that is in a year's time. So we'll denote it with FV subscript 1. And how did we get that amount? We grew our $100 by the amount of the interest received and ended up with $105. 100 our initial amount plus 5 interest received. Now if we want to calculate the future value at t equals 2, how would we do it? We just have to grow this 105, which is the ending amount in year 1 and thus equals the future value in year 1, by the amount of the interest. So the future value in 2 years' time, notice that I'm using an analogous notation to before, is equal to 105 plus 105 times 5% or 0.05 expressed as a decimal. So this equals 105 plus 5.25 interest received for a final amount of $110.25. You can use a calculator for this one. So we got our future value at t equals 2. We'll expand the analysis in the next video, where we will also explicitly show the mathematical relationship that links the present value to the future value. Before I close this video, I'd like to remind you that although these three amounts, this 100, this 105, and this 110.25 we just calculated, are different in absolute terms, if we take into account of the time value of money, that is, if we take them at the same point in time, they are completely equivalent. Let's move on.